Good morning, dear students. Today we are going to discuss our first chapter, Measurements and Experimentation. Chapter 1, Measurements and Experimentation. We know physics is a branch of science which is based on experiments, and these experimental studies involve measurements for accurate results. That is, physics is based on experiments and observations. There is the importance of this chapter, measurements and experimentation. And in this chapter we are going to discuss about what is a physical quantity. What is a physical quantity? Then what do you mean by the term measurement, or what is the importance of measurement? Then what is a unit? Different quantities and different unit like fundamental and derived units and fundamental and derived quantities, and systems of units, different systems of units. Okay, so you have already learned that what is a physical quantity, what is measurement, unit, etc. in your previous classes. Actually, what is a physical quantity? What is a physical quantity? What do you mean by a physical quantity? Any quantity that can be measured is called a physical quantity. A measurable quantity is called a physical quantity. A quantity that can be measured. For example, length is a physical quantity. We can measure length. We can measure length of a piece of cloth, or you can measure the length of your room or the length of your book. So length is a physical quantity, a measurable quantity. Another example is mass. Mass is a measurable quantity. Time is a measurable quantity. Temperature is a measurable quantity. If you have fever, then you can measure your temperature. That is a measurable quantity or physical quantity. So any quantity that can be measured is known as a physical quantity. And a physical quantity can be expressed like this. Physical quantity is equal to numerical value into unit. Numerical value into unit. That is, for example, if you are measuring the length of a piece of cloth, for example, length is a physical quantity. Here length is a physical quantity, and the length of a piece of cloth is 10 meter. If the length is 10 meter, then 10 is the numerical value and meter is the corresponding unit. So length is a physical quantity, numerical value or magnitude is 10, and unit is meter. This is how we can express a physical quantity. A physical quantity can be expressed in terms of numerical value and unit. Or another example, if you are measuring mass of a quantity of sugar is 5 kilogram, then mass is a physical quantity and 5 is a numerical value or magnitude, and kilogram, kg, is the unit of this physical quantity. That is, the result of measurement of a physical quantity is expressed in terms of two parameters. First one is the unit, and then second is the numerical value or magnitude, which expresses how many times the above unit is contained in the given quantity. So physical quantity is a quantity which can be measured. For example, length, mass, time, temperature, etc. are physical quantities, and it is expressed in terms of numerical value or magnitude and its unit. And now, what is measurement? Measurement is a comparison of, or it is a process of comparison of the given physical quantity with the known standard quantity of the same nature. It is a process of comparison of the given physical quantity with the non-standard quantity of the same nature, and the standard quantity used to measure the given physical quantity is called the unit. Okay, measurement is a process of comparison of a given quantity with a non-standard quantity, and the standard quantity used to measure the given physical quantity is called its unit. And that is, if length is equal to 5 centimeter, then length is a physical quantity. 5 is the numerical value and centimeter is a unit. That is, we are comparing the physical quantity length with the standard quantity of the same nature. And now we are going to discuss about the choice of a unit, or to measure a physical quantity we need a unit, and the unit chosen should have the following properties. First one, the unit should be of convenient size. Unit should be of convenient size that we can measure a physical quantity. Second one, it should be possible to define the unit without any ambiguity or without any confusion. We should be able to possible to define the unit without any ambiguity. We should define the unit, or without any uncertainty or without any confusion define the unit. Then third one, the unit should be reproducible. The unit should be reproducible means, what is the meaning of reproducible? We can convert the unit. For example, 1 meter is equal to 100 centimeter, or 1 kilogram is equal to 1000 gram. That is, we can able to convert the units. That is, the unit should be reproducible. And the fourth point, the value of unit should not change with space and time. The value should not change with space and time, or the value of unit must always remain same. Always remains same everywhere. Always remains same everywhere. That is, to measure a physical quantity, the chosen unit should have the following properties. First one, the unit should be of convenient size. Second one, it should be possible to define the unit without ambiguity. Third one, the unit should be reproducible. Fourth one, the value of unit should not change with space and time, or it must always remain same everywhere. Okay, so these are the conditions in order to choose a unit. And next is different kinds of unit. There are two types of units. There are two types of units. They are fundamental units and derived units. Fundamental units and derived units. Fundamental and derived units. Then, what is a fundamental unit? A fundamental or basic unit is that which is independent of any other unit. Which is independent of any other unit, or which can neither be changed nor be related to any other fundamental unit. Or independent units are fundamental or basic unit. They are independent units. Then, what is derived unit? Derived units are those which depend on the fundamental units, or which can be expressed in terms of fundamental units. Derived unit depend on fundamental unit. Depend on fundamental units. For example, length is a fundamental unit. Length is a fundamental quantity and the corresponding unit is meter. Meter is a unit of length, so it is a fundamental quantity. Then, you know the physical quantity area. Area is equal to, we know the equation, area is equal to length into length or side into side. Okay, then what is a unit of length? Meter. Meter into meter, that is meter square. That is, for the measurement of area we need to measure length and breadth in the unit of length. That is, area is a derived quantity and the corresponding unit is a derived unit. Or speed. Speed is equal to, we know what is the expression for speed? Distance by time. Speed is a physical quantity, distance is a physical quantity, and time is also a physical quantity. What is the unit of distance? Distance is expressed in terms of meter and time in seconds, and speed is equal to meter per second. That is, the unit of speed depends on the unit of distance, that is meter, and the unit of time, that is second. That is, speed is a derived quantity and the corresponding unit meter per second is a derived unit, because this unit depends on the fundamental units of length and time. Okay, so there are two different types of units, fundamental units and derived units. Fundamental units are independent units, or fundamental unit is that which is independent of any other unit. Example, length, mass, time, temperature, etc. are fundamental units. Quantities and the corresponding units are fundamental units, and derived units are those which depend on the fundamental units. For example, meter per second, the unit of speed. Meter per second square, the unit of acceleration, are examples of derived units. Okay, and there are different systems of unit. Systems of units include, we know there are three different quantities. The three fundamental quantities are length, mass and time. Length, mass and time are the three fundamental quantities, and in terms of these three fundamental quantities, the following systems are used. The three systems of units are, first one, systems of units are CGS system. In CGS system, C represents length, that is, length is represented in terms of centimeter, that is the letter C. Mass in gram, G, and time in second. Length in centimeter, mass in gram, and time in seconds. Okay. In FPS system, length is expressed in terms of foot, mass in pound, and time in seconds. And in MKS system, length is expressed in terms of meter, mass in kilogram, and time in seconds. So the three systems of units are CGS system of unit, FPS system of unit, and MKS system of unit. In CGS system, length is expressed in centimeter, mass in gram, time in second. In FPS, length in foot, mass in pound, and time in second. In MKS, length in meter, mass in kilogram, and time in second. So today we discuss about physical quantity. Any quantity that can be measured is a physical quantity, and a physical quantity is expressed in terms of its magnitude or numerical value and unit. Numerical value and unit, magnitude and unit. Then length, mass, time, temperature, etc. are examples of physical quantities. And there are two different types of physical quantities, fundamental quantities and derived quantities, and the corresponding units are fundamental units and derived units. And in order to choose a unit, we should follow the following conditions. That is, first one, the unit should be of convenient size. Second one, it should be possible to define the unit without any ambiguity. Third one, the unit should be reproducible. And fourth one, the value of unit should not change with space and time. That is, it must always remain same everywhere. And the different systems of units are CGS system, FPS system, and MKS system. That's all about need of unit for measurement and different kinds of unit. Thank you.